Spare change, we are going to talk about the difference between physical changes and chemical changes. After this, we should know and be able to explain the difference between the two types. We should be able to look at models on a small scale and substances on a big scale in order to understand the difference. We should be able to look at a model and tell if it's physical or chemical changes. And we should be able to determine if the change is physical or chemical based on a chemical equation. Okay? So, moving forward, a physical change is changes where the substance retains its chemical properties. The substance itself is unchanged. Though the particles of the substance, they change their position, they move around. But the particles themselves do not change. Essentially what that says is you end up with the same particle that you started with. So a physical change, if you guys can liken this to Legos, like if you build a bunch of different things with Legos and you play with those and you move those around, moving the different like Legos groups around, that is like a physical change because the individual things that you make out of Legos aren't changing, but you're moving them around. So that's why it's like a physical change.
A chemical change to a Lego would be like burning it?
A chemical change, well, I'm using an analogy. A chemical change, we'll talk about that in just a second. Okay? So, don't interrupt. If you have something to say, raise your hand. You can write one or two examples. So some examples of physical changes are ice melting, sugar dissolving, tearing paper, hammering a metal, increasing temperature, erosion, mixing and making a solution. Look up here, guys. Don't interrupt me. So these are all examples of physical changes. In ice melting, you have water particles. Sit up. Okay? Sit up. Sit up like normal. There we go. So, ice melting, we have water particles. Before and after, they're still the same H2O particles. Sugar dissolving, you're making a mixture. You're mixing up the water particles and the sugar particles. You're taking them, but you're not changing the individual particles of sugar. Like when you put sugar in your coffee, you're making sucrose solution. It appears to go away, but what's really happening? Is it still there? Yes, Oscar?
No, I don't want to interrupt you.
Okay. It's the sugar is still there. How do we know the sugar is still there? The taste. We can taste the difference. The paper, if we rip a piece of paper apart, it's still paper. Yes, Oscar?
It's like, you know how there's chocolate?
Mm-hmm.
Like, what if you put almonds and peanut? Doesn't physical change?
Yeah, you're just mixing them up. Now, if you grind them up and then you cook them, that's a chemical change. But if you just mix them up, mixing particles together, that is just physical. Yes, sir?
You know what I think of when it's like little samples?
What's that?
Like if it's like sugar and salt, I think of like like a bunch of friends hanging out. It's like they're still the same. They're just all together.
That's great. Yeah, you're mingling them up. I like that. So let's move on to some chemical changes. So chemical changes are changes where the substance has new chemical properties. The substance itself changes. Atoms are bonded differently than before, but the particles themselves do change. You have new particles that when you started with. If you're thinking about like Legos, that would be like you're taking apart the Legos and building them in a different way. You're not just moving them around. You're actually removing the Legos, how they're bonded to each other, and putting them together in a different way. That's like a physical change. Not just playing with them, but actually making a new type of structure. Oops.
Achilles, what you doing?
So the key thing here is that we have different particles than when we started. Okay? So some examples are water hydrolysis, combustion, decomposing bleach, which happens, that's why it cleans so well. If a fruit rots, would cutting a fruit in half, would that be a chemical change or physical?
That's a physical change because it's still the same.
Yeah, it's still the same, but rotting fruit, you're changing the actual fruit.
Because it's
That's why
moving.
it's crusty.
It's gross. It gets
Plus
gross.
shit.
Rusting or oxidation of a metal, cellular respiration, and photosynthesis were two that you guys talked about in biology. And there's a lot more examples of chemical changes, and we're going to talk about a lot of those in chemistry, as well as some physical changes too. Chemistry being a physical science. So you don't have to copy all these,
Why
just
is
one or two.
photosynthesis a chemical change?
Photosynthesis, what that does is that takes water and carbon dioxide,
And it makes oxygen?
and it makes oxygen and glucose.
Oh.
So you're taking the water particles and the carbon dioxide particles, putting them together in a different way through a very complex process. You guys studied that last year. I think it was called the Krebs cycle. And is that right? I don't remember. So you're putting them together so that it can be useful for the plant.
Mm-hmm.
So it's very interesting, and I know you guys have talked about that before. So you guys don't have to copy all these down. Just listen and look up here. So here's some modeling. And guys, I have a couple cool animations, so just watch this up here. So a physical change, Christian, just watch this for a second, okay? Okay. So in a physical change, the key thing is we start off with water here, and we end up with the same water particles from a liquid to a gas. You see, we have H2O. We start with that, and we end with H2O. And we just move around the particles themselves. The particles, is in a liquid, they're compact, they're close together. Whereas in a gas, they're very spread out. They're even more spread out than this diagram allows me to. But they're very spread out. The key thing, substance and particle remains the same. Still H2O that we started with, we end up with H2O. Nick, look up here. Okay. So if you look at the particles, so if you looked at this, you could tell it's a physical change because we start off with H2O particles and we end up with H2O particles. Okay? In a chemical change, this is water hydrolysis. Hydrolysis, hydro meaning water, lysis meaning to break, to lyse. So what we start off with H2O particles. And then we end up with hydrogen particles and oxygen particles. So the key thing is, we're taking H2O particles, we're rearranging the atoms into new arrangements. You're taking apart this H2O and you're rearranging it in terms of H2 and O2. Okay? Does that make sense? Yes, Sarah?
Oh yeah, like with air conditioning.
Yep.
Let's go a little box.
So the key thing is the substance changes from the reactants to the products. You don't have to. It's already in the last part. I wanted you guys to see. So if you guys look, check out that little animation. The substance itself is different before and after. Okay? So these are objectives.
Again?
I just wanted you guys to take a look at those again, especially if you watch the video, just to see if we got through what we needed to get through, because that's what you guys are responsible for.